If you think that quote was bad, wait till you see the video. Somehow, against all reasonable odds, David Berlinski is considered to be a philosopher. The quote I used for the introduction shows that maybe that epithet is too easily conferred on people. It also shows that while he may know a lot about evolution, he understands next to nothing about evolution. He's also a mathematician and seems to think you can apply mathematics to evolution. So let's just examine that. Evolution starts with a mutation, a random event that cannot be predicted by mathematics, either when it will occur or where it will occur, either geographically or in what species or in a gene sequence. Once a mutation occurs, the organism that has it must be able to survive to breeding age before it can pass that trait on to its offspring and succeeding generations, assuming it's beneficial. Think of all the random things that could occur before then. Getting eaten by a predator, dying of an infection, or some bloody great meteorite crashing into the earth somewhere near the Yucatan Peninsula. I think that occurred once. The selection pressures used by evolution aren't random, but the organism has to survive perhaps years of random events before it gets to the stage where those traits are selected for. It just can't be worked out mathematically. Mathematics can predict certain things like possible trends or propagation of virus in a population, but even they are subject to possible upset by random events. Let's look at a brief video called Dr. David Berlinski Refutes Evolution in Under 5 Minutes. You just gotta know that a title like that is a real challenge to someone like me.
It's tough to say because we're not dealing with a theory in any sense in which, say, a physicist would recognize the theory. We're dealing with a collection of anecdotes, a certain point of view, a series of hunches.
Anecdotes, points of view, and hunches. That's a very crude way of putting it. It's like they just sit around, throw shit at the wall, and see what sticks. But many scientific ideas do start out as just ideas, hunches, whatever, on the part of whoever comes up with them. But it's based on the person's knowledge of the subject, relevant related disciplines, and what they can gather from that. Give biologists credit for approaching evolution scientifically rather than just being professional butterfly collectors.
I would say that the most outstanding, the salient points are, first of all, the fossil record. Which is simply mystifying. We can't make much sense of the fossil record. It does not sustain any kind of Darwinian prediction that can be intelligently derived from Darwinian theory, and it doesn't seem to sustain anything else as far as I can see. It's a perfectly mystifying record. That's one obvious point. I'm not talking just about the Cambrian explosion. I'm talking about everything that doesn't make a whole lot of sense in the fossil record.
Garbage. The fossil record supports evolution impressively well. And even though it's far from complete and always will be, the embarrassment of riches recovered so far is more than enough to show that evolution has occurred. And it is not doubted by any significant percentage of scientists in the many branches of biology.
Second point, we have never been able in any way theoretically to examine the central Darwinian claim that natural selection and random variation can account for a great deal of complexity.
More crap. A cursory study of biochemistry shows that mutations occur and can be weeded out, ignored, or selected for, and that these selection pressures will allow for those mutations to cause an organism to die, carry on, or through gradual change, become an organism that can no longer successfully mate with its own ancestors. Can you say speciation? Or will you just stick your fingers in your ear and go blah, 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 blah?
If you look at the history of physics, for example, what did Newton do in the 17th century? He said, well, the planets are being attracted to the sun by a force. It's not any kind of force, it's a inverse square force. And then he went and showed that if you make that assumption, the result will be an orbit that conforms exactly to the observed orbit, say, of the Earth or of Mars. It will be a conic section. And then he proved the converse, that if it's a conic section, the planets must be attracted to a central source by an inverse square law. There is nothing like that in biology, in Darwinian theory. A kind of a canonical demonstration that this mechanism, random variation, natural selection, is adequate to the generation of this level of complexity.
My previous statement about mutations also occurs here, but perhaps he's thinking that as a proper scientific theory, the theory of evolution should be able to make predictions. Well, it does. And we can go all the way back to Darwin himself for that. In 1862, he predicted that the Star of Bethlehem orchid, which holds its nectar at the bottom of a tube about a foot long, would probably, like other related orchids, be fertilized by a hawk moth with an equally long proboscis. 20 years later, such a moth was discovered. The lifestyle of the naked mole rats was predicted based on similar colony animals before their lifestyle was investigated by scientists. If you want your mind blown, look up naked mole rats and how their colony system works very much like termites or bees. The general location where Tiktaalik, an intermediate form between fishes and amphibians, was discovered was based on extrapolating from what would have been expected of just such an animal, the habitat it would have required, and the time it would have existed. Niels Schuben took a team there, and they found it. Mr. Berlinski, that is a prediction.
Third evidential piece of the puzzle. Look, you turn to the serious sciences, you turn to general relativity or quantum mechanics. I can program a computer with the equations of general relativity or with the equations of quantum mechanics, and I can say, all right, what are the consequences? I can actually see the consequences emerge in a simulation. We can't do any of this in biology, and that should prompt any reasonable person to ask, why not? If this is such a simple mechanism, which could easily be programmed on a computer, how come we can't set up a computer and create something of biological-like complexity? How come we cannot see the unfolding of an evolutionary process the way we can see the unfolding of an evolutionary process in physics?
Perhaps because they are entirely different subjects, and whatever methods of investigation apply to one may not apply to the other. Chemistry, for example. You combine chlorine and sodium, you get salt. You combine iron and oxygen, you get rust. But you cannot use the laws of chemistry to investigate the physics that goes on in the heart of a star when particles are smashed together to form heavier elements. That is physics.
This is a very serious question. I've looked at all the genetic algorithms. I'm trying to write a genetic algorithm myself. And the sheer fact is, without a tremendous amount of very special manipulation and ad hoc constraints, the computer is not going to generate anything realistic if it uses Darwinian mechanisms, and it will generate something realistic only if it doesn't use Darwinian mechanisms. This is an important point. 50 years after the computer revolution began, we have a splendid tool for assessing the intelligibility and viability of Darwinian theory, and everything that we know, and I think this is the uniform experience of anyone working in genetic algorithms, indicates these mechanisms will not work. They will not work for their intended purposes.
I will freely admit that I know nothing about genetic algorithms, but a quick Googling indicates that they are used mainly to predict the evolution of computer systems, likening them to genetics, and the design of mechanical systems, not biology. I'm willing to be corrected on that.
And finally, there's the utter absence of laboratory evidence. I mean, random variation, natural selection, we should be able to start manipulating organisms. When we look at dogs, no matter how far back we go, it's dogs. When we look at bacteria, no matter what we do, they stay bugs. They don't change in their fundamental nature. There seems to be some sort of an inherent species limitation, and we have no good explanation for this in terms of a Darwinian theory.
We've been manipulating organisms for thousands of years, and in the lab for decades. Have you never heard of a fruit fly? And again, he completely ignores the facts of the fossil record. The incredible oversimplification regarding dogs and bugs is worthy of Kent Hovind or Ray Comfort. It almost makes me wonder if he's taking all this seriously or just trying to retain a steady paycheck.
We should have far more flexibility, far more plasticity under laboratory conditions than we actually do if Darwinian theory or anything like that were correct. What we see in nature, what we see in the laboratory, is very highly bounded variation, cyclic variation, as for example finch beaks in the Galapagos Island. That's about all we see. Small variations. Why is that if Darwinian theory is correct? These are evidentiary points that I think need to be stressed, need to be examined openly, honestly. And they never are, of course. Never are.
They have been repeatedly addressed by the scientific community, which is why you rarely hear them discussed, until some pontificating philosopher feeds their own ego by looking down their nose and trying to appear so much smarter than the common herd. I don't know if simple homegrown wisdom is taught in philosophy classes, but here's a piece you may wish to take to heart. Better to keep your mouth shut and have people think you're a fool than open it and remove all doubt.